Okay, so we're in section 12 of the notes where we graphed, conic sections. And what I'm going to do is go through the Sage software again. All right, so we're at this stage of the game over here. Again, for students that want to try this online, just go to that website, www.sagemath.org, and then use the interactive CoCalc Sage worksheet. And it works nicely. Again, if you're not thinking about moving forward in STEM, I'm not going to say this is terribly important for you because you probably never come across a computer algebra system. All right, so what I want to do is I want to just, go to my instance of Sage. I run it on a terminal. Again, it's really going to look the same if you're running it online. The difference might be the speed at which it goes online. It can be very slow online sometimes. X and Y are variables. Again, it's a good habit to get into in defining your variables when you're dealing with software or programming languages. So I define two variables, X and Y. And now what I want to do is implicit plot. The reason for an implicit plot, I don't want to spend time solving this thing for X or Y. All right, so implicit plot, and I'm just going to go back to the copy paste. Before I go forward on that, I want to claim though, looking at that, it's 9y squared minus 4x squared plus 54y plus 32x equals 19. Just looking at that, certainly not doing any work, I'm going to say that should graph out as an hyperbola. Let's take a look, hit the return button. And what do I get? I get the hyperbola. All right. Now, granted, I don't think it's a terribly good picture, but it's enough for me to know something about the picture. All right. Like I could probably determine, what the vertices by looking at that picture. But here's the deal. I still have to do handwork to get those vertices, right? The foci, the center, blah, blah, blah. But I got a picture that helps me, and it's not bad to have a picture. All right, let's take a look at the next one. And again, I'm just doing a copy paste. And this over here. And what do I get there? Oh, before I should have said what I was expecting to see. What am I expecting to see? Well, looking at the original function, I shouldn't say function, looking at the original relationship, it's 14x squared plus 36y squared. I'm expecting to see an ellipse. And I am seeing an ellipse right over here. All right. So someone's going to say, do you think you could do another problem using this code as a basis? And I think you could. All right. So for example, let me just go back over the notes. And I'm just going to scroll back. Yeah, tough problems, these optional ones, right? Again, options are nice to have in life. All right, so let me look at this one here. I'm going to scroll back. And you know what? I think I'm going to do this one here. All right, so what I'm going to do is just go back to my Sage. And I'm going to see if I can do it. All right, so I'm going to say implicit plot. Remember, if I make a mistake, it's not going to blow up. What do I see? X plus 3, quantity squared, divide by 25, minus, whoops, sorry about that, minus y minus 1, quantity squared, divide by 16, equals 1. And then the question is, what kind of range do you want for the x and y's? Well, you know what? I didn't do any work. So what I'm going to do is I'm going to look at the picture. And what's the picture over here? It looks like, the x's are going between, again, it's rough. I'm not saying it's exact, but it looks like it's between minus 20 and 20. And it appears the y's, and again, I'm looking at this picture over here, I'm going to say minus 13 to 13. All right, I'll try that. Remember, if I type in something incorrect, it's not going to blow up. Don't worry about this. You're not going to break anything. Oop, I made a mistake there. Let's see what happened. So I have to read this, and this gets really tough. So, I see it now. And I'll tell you where I see it. I didn't put the double equal sign down there. So I'm gonna copy. I'm glad I made an error because you guys are gonna make errors too, right? And let me copy this. I don't want to type that again. Let's see what happens if I get it right this time. Yeah, I got it. So someone says, well, you know what? That's a picture, and the picture does look roughly like this one over here. There is trouble though. I got to be honest with you. The picture in my notes is far better than the picture that Sage gave me. Now, I'm not saying you can't get Sage to make a nice picture too. I'm just saying it takes a lot of work. It takes a lot of work to get there. All right. So I want to go to commercial software, and I'm going to go to Grapher. All right. So I'm going to go to Grapher. And what I want to point on Grapher, what I did was I typed it in. So I want to point out what I typed in. We'll go through it one step at a time. I typed in the relationship. What's the relationship? X plus 3 quantity squared over 25 minus y minus 1 quantity squared over 16 is equal to 1. I typed that in. I also typed the center in. What's the center going to be? It's going to be a point. That point's right over here. What's the center going to be? The center is going to be minus 3, 1. I actually typed it in, minus 3, 1. I typed it in. What else did I type in? I typed in the vertices. Let me go through that with you. There's a right vertices. It's right over here. And what's the right vertice going to be? 2, 1. They're listed over here. What's the left vertice? It's minus 8, 1. It's right over here. All right, let's keep scrolling. I typed in the foci. There's a right one. It's over here. And what's the right one going to be? Minus 3 plus root 41. Again, you'd expect it to go through that work to get that, 1. The left vertex, right over, I'm sorry, the left, did I talk about vertex? I'm sorry, we're doing the focus, I'm sorry. The left focus over here. What's that going to be? Well, minus 3 minus root 41, 1. And they're written down for you. Again, you have to be able to do that by hand to get that. I did not ask software to do that. I did that by hand to get there. I also got the asymptotes, where the asymptote is going to be y equals, 1 plus 4/5. That's a positive slope as this asymptote over here. And the other is going to be 1 minus. And those are supposed to plot it down. Now, what's nice about this? I'm getting a better picture. I have good control over the picture too, including I could drag this thing around. I could change the scale. I could make it different colors. For example, here, let's say I want to make it more bold line. I could do that, change the color of it. I could change my points over here. I could change the color of my asymptotes. You got lots of choices when you're using commercial software. When I say choices, easy choices. I'm not going to say you can't do this with Sage. You can. You can do the same thing, get really, really nice pictures using Sage. What's the problem with using Sage? Well, it's really the same problem as when you're using any other product. You've got to learn that product. How do you learn that product? By trying it. Initially, you're just simply using it, sort of like copy paste, that kind of activity. At some point, you try to modify what you're doing, reuse code, to be able to graph something out. And you should be able to do that, reuse code to be able to do something. Now, granted, here's the deal. You're getting your feet wet. You're not an expert at this, but you want to become an expert if you're going to go into a STEM-related career. And that is like engineering, some field of scientific endeavor, or mathematics. All right, thank you.